Greetings, the Astro 30 here, and I have an LM3875 power amplifier IC sitting here. The LM3875 is a fairly old IC made by National Semiconductor, and there's actually a series of three of these ICs. There was the LM3875, the LM3876 and the LM3886 respectively, and the only difference between the 3876 and 3886 was the latter two featured a muting facility. The 3875 does not. It's just basically, well, we'll have a look at the data sheet for it in a minute. So today's little project will be building this little IC amplifier. And good thing about this one is it's already an isolated package, which is nice. So I don't need any sill washers or anything, but you still need heat transfer compound between this and the heatsink that it mounts to. This should be able to produce up to 40 watts into 8 ohms at a plus minus 35 volt rail. I'll be running it on plus minus 30 because that's the maximum I can get out of my DC power supply. As I said, these are an old IC, so I don't think National Semiconductor make these anymore, or have done, so if you find them new like this, it's most likely a Chinese knockoff like pretty much everything else. And I'll also be making a printed circuit board for it to go on to make things easier. There it is there. And so you may notice that I've got a piece of clear acetate here. I was trying an experiment, and I believe the length of time it took to develop a PCB was because I was using that semi-transparent tracing paper and the light wasn't penetrating through it enough. So as well as this being an experiment, I'm also going to double my exposure time from 90 seconds to 3 minutes, and I already did the other night try some of that clear overhead transparency to make a circuit board, and this is another mute circuit board for that subwoofer preamplifier that I haven't finished yet. But yes, I said I wasn't going to make another board for it because I stuffed up the routing or whatever, but I thought, well, might as well. I wanted to test to see whether or not the overhead transparency worked better than using tracing paper, and to a point it did. Anyhow, that's getting off topic. Let's have a look at my enormous penis. No, we'll have a look at the data sheet quickly for this IC. Now originally it reckons that it can deliver up to 56 watts. Well, it probably could at the absolute maximum power supply that you can use on it, which is 82 volt with a signal input, and in bipolar terms that would be plus minus 41. Anyhow, so the features are 56 watts continuous average power output into 8 ohms, 100 watt instantaneous peak output power, output protection from a short to ground or to the supplies by internal current limiting circuitry. Although I have had some blog posts that I've seen that say that the short circuit protection on these, the 875 and the 876 etc, don't work very well, but anyhow. Output voltage, output over voltage protection against transients from inductive loads. Supply under voltage protection, not allowing internal biasing to occur when the plus minus voltage rail is less than 12 volt, thus limiting turn on and turn off transients. So that basically means that when the IC is first turned on, it has a slow rise at the input before allowing the output to connect, because the biggest thing that causes thumps through in a speaker is not the power amp itself, it's the preamp connected to it. So it will temporarily mute the input until the supply rails come up and stabilize, and then allow sound to come out. And the same as when you turn it off, it'll take a while, but as soon as the caps on the supply start discharging and it gets below 12 volts, the amplifier cuts its input out and you shouldn't get any thump, theoretically speaking. So here's their typical application circuit. They say to use a 20 kilo ohm as the feedback resistor, but 22k is fine. They'll give you a gain with a, in this configuration with a 20k and a 1k here, they'll give a gain of 21. And with a 22k they'll give you a gain of 23. So as I say, it only uses 5 of its pins. There is 11 pins in total, so only half the IC is really being used. So that would make that seem, well, what's the point of having all these extra pins here that have no connection to them? Well, it's all about, I guess, cross compatibility with the other ICs in the same series, except the 7.6 and 8.6 IC have slightly different wiring requirements. But because of all these other pins that have no connection, the ones that are in use are the same throughout the 3 types of devices. And so even if the say pin 11 and pin 9 were wired together for the 7.6 and 8.6 respectively to work correctly, it will not affect the 7.5 at all. The 7.5 will still work in there. And the same as having the resistor and capacitor for the mute pin on the 7.6, 8.6 won't affect it on this, because that's not even connected on this particular IC. But the parts can be there and these components will be interchangeable. That makes it one great thing about that. But as we can see, it's just a standard op-amp circuit. There's nothing really that spectacular about it. So we'll take a look at my enormous pen. No, we'll take a look at the absolute maximum ratings. The supply voltage is 94 volt. That's single-ended, with no input signal, and 84 with an input signal. I meant 84 volt, not 82, as I said before. So that's basically in single-ended, and they're saying over here V plus plus V minus, so that's them 2 voltages added together. So we halve that, that gives us 42. So the maximum supply rail you can apply to this IC, or the LM3875 anyway, is 84 volts, or plus minus 42 volt. And that should give you the output power of 56 watts at that voltage. However, when running into, say, 4 ohm loads, I wouldn't run anywhere near that voltage. But it should sit nicely at plus minus 35, no problems. And so this is my schematic. Now, the interesting thing about this schematic is the output coil, which the reason they have this 0.7 microhenry and 10 ohm resistor in parallel with each other on the output is when driving highly capacitive loads, which is any loudspeaker connected on a long cable run. However, in the real world, that's not really an issue, because most speaker leads don't really exceed any more than about 5-6 meters anyway. But unless you're in a really large room, or even in a cinema, and have hundreds of meters of cable. But yeah, the interesting thing about the coil is it's made up of 0.4 millimeter enamel copper wire wound around the resistor itself. It's 10 turns of it. And this circuit is actually borrowed from a silicon chip article back in 1999 I think it was, using the LM3875T, and they did the same thing. And even when they used the LM3886, they still wound a coil around the 10 ohm resistor. So that's the way I'm going to go. It saves board space and it's a lot easier, I guess. Maybe not. So we've got two 2 amp fast blow fuses to protect the IC in case there's an internal fault. Input over here, an RF suppression capacitor here with 1K stopper resistor to stop it picking up any radio frequencies at the input. We have a 1K 22 microfarad capacitor here in the gain network, 22K feedback resistor, which will give us a gain of 23 as I previously mentioned. And there's the Zabel network there, consisting of a 2R7, which is a 1 watt device, and a 100N capacitor. That's all there is really to talk about the circuit there. It's marked as plus 30 volt, minus 30 volt, but it can be plus minus 35 for all that mattered. You would only probably choose the plus 30, minus 30 if you're going to drive 4 ohm loads, because the IC is limited in its output power when you increase the power supply rails when driving 4 ohms. 8 ohms not so much, but that's the schematic. I'll make this available in the description as a link. You can download it, have a look at it. But right now I'm going to get set up and make this PCB, and then we'll come back when I've done that. Yep, 3 minutes is key for exposure time, and this turned out much better than any board I've made so far, with development anyway. And it only took about a minute and a half to develop in an average temperature of 14 degrees Celsius. So this Kinstan pre-sensitized PCB, together with that exposure box, plus clear overhead transparency for the artwork, and 3 minutes exposure time, works wonderfully. So now I've found what my sweet spot is for exposure and development of the Kinstan pre-sensitized PCB material, and I don't have to spend 20 minutes trying to develop the frickin' PCB. I can now move on to etching it. Penis! I have no idea what started that. Anyhow, I came up with that stupid frickin' penis when I was cutting the board to size. Anyhow, apart from being immature, I've got the board drilled, cut to size, and I've got a coat of the PCB lacquer on there, and I'm just waiting for it to dry. I'm constantly farting and they stink. Anyhow, just gotta wait for that to dry, and then I can move on to assembly. Okay, so it's ready for assembly time now, and well, I'm going to put on all the components, including the IC, apart from the 2R7, because that's a resistor and inductor combo. But everything else will go on there, and fuse holders, connectors and stuff. And we'll do that in time lapse, just for something to do, and then I'll come back at the end there and I'll show you how I'm going to wind the coil around this resistor. Anyway, let's get started. Okay, that's most of the soldering done. The IC's in, didn't overheat it. Everything's in but that 10 ohm resistor. I said 2R7 before with the coil wrapped around it. It should have been 10 ohm with the coil wrapped around it. I got the two resistors mixed up. That's alright, they're in the right places. I've just got to wind my 0.4mm diameter enamel coppered wire around this. It's 10 turns, which should make 0.7 microhenry. So the easiest way to do that would be to first bend the leads of the resistor so that they're the right size to fit in the hole, or holes, like that. And remember, with 1 watt devices, I like to stand them up off the board so there's an air gap there. So that will fit in there nicely. So the easiest way to do this would be to mount it in something and get the wire ready. Okay, so there's always a use for this tool, but what I'm going to do is I'm going to pre-tin one of these legs. Actually, I might pre-tin both of them, it'd be a lot easier. And that's where the the wire is going to be soldered to. Plus that also allows it to stand out from the board a little. I'm not sure how long 10 turns is, but I think it's no more than 30 centimeters anyway. It's about 20 centimeters or something. So I need a knife, and I'll just move him out of the way. And I'm just going to scrape off the end of the enamel copper wire and rotate it around a few times. Just so I can tin the end of it. Alright, so after doing that, I'm going to tin the end of the wire. Like so. It probably would be a better idea to wrap it around the leg of the resistor. But whatever works. And once I've wound the coil, I can always re-tin it. So that's the wire on the resistor. It doesn't really matter which direction you wind either. So I'm going to leave it in the claws, and I'm going to go this way, I think. So that's 1 whole turn. 10. Now I believe I've got 10 turns there. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, 10. So now, with it out coming off the resistor, I need to get it to the other end of that resistor. So again, I'm going to scrape the end, as much as I can anyway, of the enamel off. It's very awkward now, but just enough so it'll tin anyway, but I'll cut it in a minute, but I'll just scrape it before I cut it. So I can take this out of the jig. It's still hot. No, I'm kidding. Get rid of this tool because I don't need it anymore. Penis! Now, right, so I'm going to put this resistor now in the board. And I'm going to solder the conjoined part in. Okay, that's now soldered in. And there we go. That is the solder assembly of the circuit board complete. Straighten that up a bit. So that's now ready for testing. But before you test any power amplifier of any decent level of power, it's always good to mount it to a heatsink, or else the power amplifier is not going to last very long, and that's crooked too. Let's see if I can get that straighter. That's a bit better. Yeah, so we need to mount that to a heatsink. Say hello to my little friend. So this is JCar Catalog HH8570, and it's 105 long by 55 millimeters high. So this is more than adequate for the LM3875. Might be a little under, but it will do the job. Yeah, so I need to get that off. I need to mark it out so I can mount my circuit board to it. But what I'm going to do is I've got two holes here at the front for the standoffs, so I'll put the standoffs on. And I've just noticed that board's a bit warped. Wow. Yeah, quite a bit of warpage in there. And then I'll just, you know, come up 10 on the heatsink there to wherever that hole lines up. Drill a hole, put some compound on the back of it, put a bolt and a nut, and Bob's your auntie. So, let's get that done before I start testing. And there she be. It's all mounted to the heatsink. I didn't actually use a nut in the end, I just drilled a 2.5mm hole and tapped it with a 3M tap. And then just wound the screw in. It's got some way too much heat transfer compound on there, but got the fuses in, got all the fly leads, whatever you want to call them, to connect my leads to it. Now it's time to hook it up to the DC power supply, and I'm going to have the current limited to about 1 amp, and I'm going to start off at 0 volt and slowly wind the voltage up, and see if there's a jumping current, like a huge jumping current. Then we know there's a problem. This being a Chinese knockoff of the LM3875, I have no idea what's going to happen. I have built this circuit board before. I actually built a little bench test amp back in 2009, and I think there's a video up on my channel about that. But yeah, I used 2 of these boards and it worked fine. So I know the circuit works, but I don't know if that IC does. But that's just what we're about to find out. Okay, I've got the power supply set up. I've also got the multimeter hooked up across the output to measure the DC offset. Power supply is at 0 volt. We're around about 1 amp current limit. So I'm going to turn the load on. Of course, not much is going to happen until I slowly start increasing the voltage. So we're now at 0.3 of a volt. 1, 2, 3, 9, 10. We've got an overload condition on the multimeter for some strange reason. Alright, we're at a negative. Okay. We're not drawing excessive current though. Once we come up in voltage, that DC offset should disappear. Well, that's interesting. We have a DC offset at the output. We're not drawing any current, which is strange. We're at 23.9 volt, but we should not have any DC offset. That is not right. So that means that that IC doesn't work. There's a surprise. So it'll be unbolt that and try another IC. Okay, change the IC, so I'll repeat the test again. I'll start at 5.6 volt, current low, and we'll look at the output. Turn the load on. We still have a negative output DC offset. That's not really correct. So I don't know. There shouldn't be any DC on the output, but yeah, there is. It's 20 mA current draw though, but it's, yeah, 29 volt. That's way wrong. I don't quite follow that. Right, so the only thing I can think of is these ICs, because I've tried 2 of them now and they're both outputting a DC offset. Unless they're operating in class A, but they shouldn't be. There should be class A, B. There should be no more than 100 millivolts on the output. However, these are the LM3875TF. I really need the LM3875T. So JCar still sell them, except they're 19 bucks each. I paid probably 19 bucks for 5 of these, but it pretty much looks like these are useless. As I said, it might be operating in class A. I doubt it. It's only drawing 20 mA of current according to the power supply, but it's outputting close to the positive full voltage rail there, which is not right. So yeah, I'm going to take a trip down to JCar and get myself a another LM3875T, a proper one. The one I'm getting will be a non-isolated package. For all intents and purposes, it doesn't really matter because, well, yeah, it's only going on this heatsink and it's not mounted to a chassis. So, anyway, we'll resume once I have returned. Okay, and I'm back with some new ICs. Unfortunately, they look exactly the same as what I've already got, until further investigation. Now, if we look at the face of this IC, I don't know how else it's going to show up on camera, that is an unusual texture on the face. It looks like it's been shaved with something, and the text is a little smaller than the ones I've got in the bag over there. Just take note of that, JM1328RD, and the one on here is the exact same number. I'm assuming that's the batch number. But if we now look at the new IC, which is more expensive than what I've got, that weird shaved texture is not on the face of this IC. And that one says JM23ACE3 as compared to JM1328RD. So they're completely different numbers, and the text is different. That says V1, that says V8, so that's the V8 engine. That's going to have a lot more power. I'm thinking that these are fake. Now, yeah, because of that weird texture. Now, it appeared to me that this one was shorted to the negative rail, and the one that's in the module now is shorted to the positive rail. So I'm just going to confirm that. Okay, I've got the multimeter set up in the background here. I've got to find my positive probe. So I need to go between pin 3 and pin 1, which is the positive rail. So pin 3 is there, and pin 1, which is there. It doesn't appear to be shorted. Pin 4 and pin 3. Well, there doesn't appear to be any short circuit on that IC. Let's try this one. Pin 4 and pin 3. That's indeed definitely shorted. Pin 1, pin 3, there's nothing. So this IC is definitely shorted. That's hence why we had negative 30 odd volt on the output. This one doesn't appear to be shorted, but if anything, it'll be shorted to the positive rail, but it's not. It's not shorted to the negative rail either. So that IC may or may not be okay, but yeah, let's see where this is going. I'm pretty sure the ones I bought from China are completely fake. There's no short between positive and output. And there's no short between negative and output. So, what I have to do is now change that IC yet again to this one, which I'm hoping is genuine, and resume testing all over again. How fun. There's another thing I just noticed about this IC too. This is the so-called genuine one. This is the fake one I just pulled off the board. The leads are slightly different too. Different makeup. If you compare both, the one on the left is what I'm going to say is the genuine. The one on the right is the fake Chinese one. The leads are of a different shape altogether than these. These are a flat sort of lead. These are rounded leads. So yeah, it just goes to show you, even if you want to try and get these ICs cheap from China, don't bother. Buy them from a reputable manufacturer or supplier, I should say, because yeah, you'll end up with problems like I just did, and it's thoroughly frustrating. And there should be no need for this. It should just work out of the box first time, no problem. So this is the last IC I'm going to put on this board. And I know that this board is routed correctly because, as I said, I have used this circuit board before. So I know that the thing works. And it does actually work very well. So it depends on the IC, of course. So it was obvious that those ICs are junk. I think I paid about $18 for the 5 of them. So I've got pretty much 5 useless ones now. But yeah, what else is new? Okay, the new IC soldered in. Need to put some more compound on the back of that one. Not too much, because there's already some on the heatsink, so I don't really want to go overboard with it, but just put a little on there just to make the IC a bit happier. That should be plenty. Screw it back onto the heatsink. Now, I was expecting this to be the metal tab version, but no, they've got the same TF version here. Hopefully, as they say, third time lucky. Hopefully that's a working IC, because if not, I'm going to cry. No, not really, but I will be thoroughly annoyed. Okay, let me get set back up, put you on the floor and see what we get now. Everything is set back up. I've made sure that I've got the supply connected the correct way around. Everything is connected. I'm set back down to about 3.2 volt. So we'll turn the supply back on. And I can see a negative DC offset of 3 volt. But wouldn't you know it, at 16 volt, which is above the plus minus 12 volt needed for the mute circuit to engage, there is 0 DC offset. Isn't that amazing? And as I rotate the control up to 21 volt thereabouts, we're getting 30 mA current draw and 0 volts on the output. So this has been a lesson to both me and to you that always test the DC voltage at the speaker terminals of an amplifier that you don't know anything about, because there should never be any DC voltage on the output, albeit a couple of millivolt, 100 millivolt maybe at max, but you shouldn't have any DC voltage. Now I'm talking at the speaker terminals. On a class A amplifier, yes, you would have DC half voltage potential on the output, but it'll have an output capacitor. So there should still be no DC offset on the output, and according to my meter it's 0. I keep kicking something. So if I go back to the millivolt scale, I can see I got minus 20 MA there, something around about there. Nope, everything's all good, so I'll wind this up to say 25 volt. No extra current draw, so everything's fine. It hasn't popped a fuse on the module, that is, and my DC offset's remaining at negative 25 MA. Well, actually, it's not even that. It's minus 0.25 MA. So it's under 0 volt. Okay. And if I touch the input with my finger, you can see the voltage is going up and down. So that's a good indication. It's only about 30 millivolt, but it's a good indication that this IC is working as an amplifier. So very, very good. So I can probably wind the voltage up to 30 volt now, and which is what I'm going to do. And we've still got current draw of 30 MA and bugger all DC offset. So I know that this module is functioning as it should. Now we need to hook it up to a dummy load and an oscilloscope and a DDS, and we'll have a look at the output sine wave, do a power measurement at 30 volt. Plus minus 35 volt would be a little bit higher in output, but I reckon, I'm going to predict, we're going to have around about 40 watts. So rather than surmising, let's all get set up for the test. I never actually finished that last statement in the last clip there. When I was talking about always measure the DC on the output terminals of an amplifier, the reason I said that was rather than just going ahead and connecting it straight to a speaker, because if that other IC had the positive 30 volt rail across the output, connect that to a loudspeaker, say goodbye to the loudspeaker. It's not so bad when it's in a dummy load, but it'll just end up drawing shitloads of current and end up blowing a fuse. However, I've got the oscilloscope, DDS and dummy load all set up. Now all I need to do is turn the power supply on and see if we get an output, which we do. I am, however, using a times 10 probe, but I can see that I'm getting roughly 21 volt peak to peak at the moment. So if I increase my voltage to 1 volt, I can see that that's a nice clean sine wave. So if I now increase my amplitude to say 1.5 volt peak to peak, we're still not clipping yet. So change that to 2 volt peak to peak, and I can't really tell if we are or not yet. Yeah, we're starting to clip at 2 volt peak to peak, and I'm drawing around about 1.5 amp. So I'll back that off to 1.6, say. That looks relatively clean, doesn't it? We're getting 32 volt peak to peak, which is kind of interesting. And that heatsink is getting rather warm. It's not hot. So at 32 volt peak to peak, we'll say, so that's what, 16 volt peak, multiplied that by itself, gives us that, divided by our load, 32 watts. I was pretty close, albeit I'm about 8 watts off. However, that's only running at 30 volt, or thereabouts, and the supply's actually dropped down to 7.5 now. So yeah, with plus minus 35 volt, we'd expect a lot more output, and that is getting considerably warm. So I will do a sweep test on this now. There we go. Yeah, it's got much more output towards the base end of the frequencies and drops off towards the high frequencies. We're now at about 25 volt. Yeah, it's not exactly flat. We start off about 30 volt and it drops off to around about 27, 26, 25, something like that. So it's not overall flat, but it's reasonable for what it is, but we can see it is shrinking off or rolling off quite considerably. Okay, so what I'm going to do now is hook it up to a speaker, and that's getting really hot, so that heatsink's probably a little bit too small, but then I don't expect that to be running at full power. I should have used a slightly bigger one. But as I say, it'll do for a test. I mean, it is sinking the heat into it. The dummy load's cold though. So what I'm going to do is I'm going to let that heatsink cool down, because it is kind of underrated. And then I'll hook it up to a speaker and we'll do a sound test. Yeah, okay, so I've got it hooked up to a speaker, and I've got the input hooked up across this pot here, which is a 20k linear. Doesn't matter. I've got the CD player queued up ready to go, so I'm going to turn the power on and see if there's any unusual noises coming out of the output. No, there's a bit of circuit buzz there. Press the volume a little bit. Now press play. See what happens. That was loud. But it works. And that sounds bloody awesome, I must admit. I've forgotten what the LM3875 Overture IC, or actually any of the LM38 range Overture ICs actually sounded like. They do sound quite nice. I mean, the only disadvantage to them, or drawback I should say, is the fact that their total harmonic distortion sits at about 0.1%, whereas compared to today we've got better Class AB amplifiers sitting at, you know, 0.001%. So yeah, so the LM3875 with a few extra components around it is a great little amplifier. It's actually a brilliant amplifier, albeit there's a bit of circuit noise there, but if I disconnect the input, it goes away. So it's just my leads pricking up interference because they're not shielded. But yeah, the amplifier is relatively quiet when it's got no input signal. I can't hear anything coming out the speaker. So yeah, if you want a very quick and easy amplifier to drive a speaker, that's your man. Actually, any of them are. The LM3875, LM3876, just remember there's extra connections and extra components, as well as the LM3886, and the extra components and extra connections is also prevalent for that too. But check the data sheets on both of those and it will tell you what needs to be connected where. But the base circuit here is exactly the same between all three. Anyway, I hope you enjoyed this video. We found out that some Chinese people on eBay are liars and thieves, but selling counterfeit national semiconductor products. I mean, well, I really thought they only faked Motorola and Toshiba devices and some Hitachi. Didn't realise they also targeted national semiconductor, but they'll target anything. But what the fuck these are is beyond me. But they're definitely not LM3875s. So they're going to go in the bin. But yeah, it was only 18 bucks for 5 of those crappy ones, and 19 bucks for a real one. Anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying have a great day, happy amplifying, and use a bigger heatsink.